At over 2 tons and reaching heights of 14 feet when standing, Arctotherium angustidens was a giant among prehistoric predators. This ancient bear's story, from evolution to extinction, unveils surprising truths about life in prehistoric South America and the delicate balance of ecosystems. In 1935, paleontologists in Buenos Aires made a startling discovery. They unearthed a massive humerus bone that hinted at a creature of extraordinary proportions. This find marked the beginning of a scientific journey to uncover one of the most remarkable predators in Earth's history. As researchers pieced together the evidence, they realized they were dealing with a species that defied expectations and challenged our understanding of prehistoric life. The tale of Arctotherium angustidens is more than just a chronicle of size and strength. It's a window into a lost world, offering insights into ancient ecosystems, climate changes, and the complex web of life that existed millions of years ago. This prehistoric bear's existence raises intriguing questions about adaptation, survival, and the forces that shape evolution. "3 million years ago, a monumental event reshaped the biodiversity of the Americas. A narrow strip of land emerged from the sea, bridging North and South America for the first time in over 150 million years. This Panamanian land bridge set the stage for one of the most significant ecological events in Earth's recent history, the Great American Biotic Interchange. The two continents had developed in isolation, each harboring unique flora and fauna. The land bridge acted as a highway for species migration, allowing animals from both continents to venture into new territories. This massive movement of species created a melting pot of biodiversity, but it also sparked intense competition as animals that had never encountered each other were thrust into the same ecosystems. In North America, many of the newly arrived South American species struggled to gain a foothold. However, the story in South America unfolded quite differently. Prior to the Great American Biotic Interchange, South America's ecosystems had a peculiar imbalance. The continent was home to an abundance of large herbivores, but it lacked the diversity of large predators seen in other parts of the world. This created a unique opportunity for carnivorous newcomers from the north. As North American predators crossed the land bridge, they encountered a wealth of prey species that had never faced such threats before. Many of South America's endemic herbivores were ill-equipped to defend against these new, efficient hunters. This imbalance set the stage for rapid evolutionary adaptations and arms races between predator and prey. Among all the species making the journey south, one group of animals was poised to take particular advantage of this new frontier. The ancestors of Arctotherium, a genus of short-faced bears, crossed into South America around 1.75 million years ago. These early bears were modest in size, comparable to modern black bears. However, they were about to undergo a remarkable transformation. The abundance of large, naive prey and the relative lack of competition from other apex predators created the perfect conditions for Arctotherium to evolve into something extraordinary. Over hundreds of thousands of years, these bears would grow to proportions that would dwarf their ancestors and even surpass the largest known terrestrial mammalian predators of all time. Nature had bigger plans for these bears. The Arctotherium that first set foot in South America were unassuming creatures, similar in size to modern black bears. Yet, in a relatively short span of evolutionary time, they would undergo a transformation so extreme it challenges our understanding of mammalian growth limits. What forces could drive such a rapid and massive change? When the ancestors of Arctotherium crossed the Panamanian land bridge around 1.75 million years ago, they were modest-sized bears, weighing between 200 to 300 pounds. These early short-faced bears were agile and adaptable, but they weren't particularly large compared to other carnivores of their time. Their fur was likely dark, their snouts were indeed shorter than those of modern bears, and they walked with the characteristic plantigrade gait of their ursine relatives. South America's unique ecosystem, with its abundance of large herbivores and limited predator diversity, created an ideal environment for Arctotherium's extraordinary growth. This combination set the stage for what biologists call an evolutionary release. Without the constraints that typically keep animal sizes in check, Arctotherium was free to grow larger with each passing generation. This rapid size increase wasn't just a matter of getting bigger. Arctotherium's body underwent significant changes to support its new massive frame. Their limb bones became thicker and more robust, capable of supporting weights that would crush smaller animals. Their jaws and teeth grew more powerful, allowing them to crunch through the tough hides and bones of their oversized prey. The speed of this evolutionary change was remarkable. In just a few 100,000 years, a blink of an eye in evolutionary terms, Arctotherium angustidens emerged as the largest known bear species in Earth's history. The largest known specimen, an elderly male, is estimated to have weighed between 1,588 and 1,749 kilograms, 3,500 to 3,855 pounds, and stood an astonishing 3.4 meters, 11 feet tall on all fours. When rearing up on its hind legs, this bear could have reached heights of 4.3 meters, 14 feet, dwarfing even the largest modern bears. This rapid size increase represents one of the most dramatic examples of evolutionary gigantism in the mammalian fossil record, showcasing the remarkable adaptability of these ancient bears to their new environment. While its sheer size was impressive, the true terror of Arctotherium angustidens lay in its specialized anatomy. How did this bear evolve to become such a formidable land predator? The answer lies in a set of adaptations that made it uniquely suited for its role as an apex predator. The most striking feature of Arctotherium angustidens was its robust forelimbs. Paleontologists have discovered upper arm bones nearly equal in size to that of an elephant. These massive limbs were essential tools for hunting and defense, allowing the bear to topple large prey or fend off rival predators with ease. Complementing its powerful arms was a skull built for crushing. The unique shape of Arctotherium's skull, with its shorter snout compared to modern bears, earned it the nickname short-faced bear. This compact skull housed a set of formidable jaws capable of delivering bone-shattering bites. Paleontologists estimate that its bite force could have exceeded that of any living carnivore, allowing it to crunch through the tough hides and bones of even the largest prey animals. Arctotherium angustidens was built for speed as well as power. Its long legs, reminiscent of those seen in modern grizzly bears, suggest that it was capable of reaching impressive velocities. Some experts believe it could have matched or even exceeded the top speed of grizzlies, potentially running at over 40 kilometers per hour in short bursts. This combination of strength and agility would have made Arctotherium a truly versatile hunter. The bear's sensory capabilities were likely just as impressive as its physical attributes. The structure of its skull suggests a large nasal cavity, which would have housed highly developed olfactory organs. This keen sense of smell would have been invaluable for locating prey across vast distances or detecting potential threats. These adaptations paint a picture of a versatile super predator. Arctotherium angustidens was equally equipped for active hunting and opportunistic scavenging. It could take down large prey like horses and giant ground sloths, chase fleeing animals, and when carrion was available, easily tear through tough hides and break open bones to access nutritious marrow. Imagine Arctotherium angustidens in action, using its keen sense of smell to detect a herd of prehistoric horses. With surprising speed, it charges towards its prey, covering ground with long, powerful strides. A single swipe of its enormous paw brings down a horse, while its bone-crushing jaws deliver a fatal bite. In mere moments, this efficient predator has secured a meal that could sustain it for days. While Arctotherium's hunting prowess was undeniable, its true survival strategy was far more complex. Isotope analysis of its fossilized remains has uncovered an unexpected twist in its dietary habits. What other food sources did this giant bear rely on? And how did this adaptability shape its dominance in prehistoric South America? Recent studies have revealed surprising insights into Arctotherium angustidens' eating habits. Paleontologists have closely examined the wear patterns on fossilized teeth, which provide clues about the types of food an animal consumed over its lifetime. The teeth of Arctotherium show a combination of wear consistent with both meat eating and plant consumption, suggesting a more varied diet than previously thought. Carbon isotope studies have provided further evidence of Arctotherium's diverse food choices. These analyses reveal that while the bear did consume significant amounts of meat, particularly from large herbivores like horses, tapirs, and ground sloths, It also derived a portion of its nutrition from plant sources. Fleshy fruits, berries, and even tough plant materials like grasses and roots appear to have been part of its diet. The environment of Pleistocene South America offered a diverse array of potential food sources for Arctotherium. The continent was home to vast grasslands, dense forests, and wetland areas, each supporting different plant and animal communities. This mosaic of habitats provided a veritable buffet for an adaptable creature. In addition to hunting large prey, Arctotherium could have foraged for fruits in forests, dug for roots in open areas, and scavenged carcasses when the opportunity arose. This dietary flexibility likely provided several evolutionary advantages. By being able to subsist on a variety of food sources, Arctotherium could survive seasonal fluctuations in prey availability or changes in vegetation due to climate shifts. The ability to digest plant matter may have allowed it to extract nutrients and energy from a wider range of sources, potentially giving it an edge over strictly carnivorous competitors. Moreover, Arctotherium's varied diet may have influenced its ecological role in profound ways. As both predator and occasional herbivore, it could have had complex effects on the populations of prey species and the distribution of certain plants. Its foraging behaviors might have aided in seed dispersal, potentially influencing the composition of plant communities across its range. The skull morphology of Arctotherium angustidens provides additional support for its diverse dietary habits. A 2009 study comparing Arctotherium skulls to those of living bears found that its cranial structure fell between that of modern meat-eating and herbivorous bears. This anatomical evidence aligns perfectly with the dietary habits suggested by tooth wear and isotope analysis, painting a picture of a highly adaptable creature. Arctotherium's adaptability allowed it to thrive, but it was far from alone in prehistoric South America. In a landscape teeming with formidable predators, what set this bear apart? The answer lies in a surprising social dynamic that challenged the very notion of survival of the fittest. For hundreds of thousands of years, Arctotherium angustidens reigned supreme over the South American ecosystem. Its massive size, coupled with its versatile diet, allowed it to dominate a landscape filled with megafauna. Standing at the apex of the food chain, this colossal bear faced few threats from other predators. Fossil evidence has revealed intriguing aspects of Arctotherium's behavior and habitat preferences. Paleontologists have discovered Arctotherium remains in ancient caves and burrows, often alongside other animal bones. This has led to theories about the bear's social structure and living arrangements that set it apart from other large carnivores of its time. One compelling hypothesis suggests that Arctotherium may have lived in family groups, at least during certain parts of the year. This social structure would have been unusual for such a large carnivore, but it could have provided several advantages. Group living might have allowed Arctotherium to more effectively defend territories, care for young, and even cooperate in hunting larger prey. The use of caves and burrows by Arctotherium is particularly fascinating. Some researchers believe these bears may have taken over the dens of other animals, such as giant ground sloths. This behavior would have provided shelter and protection, especially for females with cubs. The presence of multiple individuals in some of these sites supports the idea of social grouping, at least during denning periods. Arctotherium's skeletal remains also tell a story of intense competition and conflict. Many fossils show signs of healed injuries, suggesting violent encounters with prey or other bears. These battle scars paint a picture of a tough, resilient animal that faced significant challenges despite its size and strength. At the height of its power, Arctotherium angustidens would have been an awe-inspiring sight. Imagine a group of these giant bears moving across the Pleistocene landscape, dwarfing other predators and sending herds of prey animals scattering. Their presence would have shaped entire ecosystems, influencing the behavior and evolution of both prey species and competing carnivores. The reign of Arctotherium angustidens was not destined to last forever. In a twist of evolutionary fate, this apex predator would face a challenge greater than any rival carnivore: a changing world. What environmental shifts could possibly topple a species that had mastered its domain for hundreds of thousands of years? Around 800,000 years ago, Arctotherium angustidens vanished from the fossil record, leaving behind a mystery that has puzzled paleontologists for decades. The disappearance of such a successful and dominant species raises questions about the fragility of even the most powerful creatures in the face of environmental change. The Pleistocene epoch, spanning from 2.5 million to 11,700 years ago, was a time of dramatic climate fluctuations. These changes manifested in South America through shifting vegetation patterns and animal distributions, directly impacting food availability for both Arctotherium and its prey. As the Panamanian land bridge facilitated movement between North and South America, new species arrived in Arctotherium's territory. These newcomers brought different behaviors, diseases, and competitive strategies that disrupted the existing ecological balance. The carnivore guild in South America diversified, intensifying competition for resources. Arctotherium angustidens, which had evolved in an environment with relatively few large carnivores, now faced rivals that were potentially more adaptable or efficient hunters. Simultaneously, some of the large herbivores that Arctotherium had relied upon for food began to decline. The reasons for these declines were complex, likely involving a combination of increased competition with newly arrived herbivores and potentially increased predation pressure from the expanding carnivore population. These factors created a challenging environment for Arctotherium angustidens. Its massive size, once an advantage, became a liability. Larger animals typically require more food to sustain themselves and are often less able to adapt quickly to new conditions. The energy requirements of maintaining such a large body would have been significant, especially if preferred prey species became scarce. The ecological pressures facing Arctotherium were not unique to this species. The Pleistocene saw the extinction of many megafaunal species across the globe. However, the disappearance of Arctotherium angustidens around 700,000 years ago marked a significant shift in South American ecosystems. The absence of this top predator would have had ripple effects throughout the food web, altering the dynamics between remaining predators and prey. The absence of Arctotherium angustidens left a void in South American ecosystems, but nature abhors a vacuum. In a twist of evolutionary fate, the giant's own descendants would fill this gap, but not in the way you might expect. How could the offspring of the largest known terrestrial mammalian carnivore become more like modern vegetarians? The story of Arctotherium didn't end with the disappearance of its largest species. Instead, it embarked on a remarkable journey of adaptation and transformation. As environmental pressures mounted, the genus responded with a series of evolutionary changes that would reshape its role in South American ecosystems. The most striking change was a gradual reduction in size. Over hundreds of thousands of years, new species of Arctotherium emerged that were significantly smaller than their giant predecessor. This trend continued through several species, with each subsequent one generally being smaller than the last. This size reduction wasn't merely a matter of shrinking proportionally. The later Arctotherium species underwent significant anatomical changes. Their limbs became less robust, and their skulls showed adaptations for a more varied diet. These changes suggest a shift in lifestyle and ecological niche. The transition from megacarnivore to omnivore or even herbivore wasn't without trade-offs. While smaller size and a more flexible diet allowed Arctotherium to survive in changing environments, it also meant giving up its position as the apex predator. Later species would have been more vulnerable to other large carnivores and may have had to avoid direct competition. These adaptations highlight the remarkable plasticity of the Arctotherium genus. In just a few 100,000 years, a blink of an eye in evolutionary terms, these bears underwent significant changes in size, diet, and ecological role. This rapid evolution demonstrates the power of environmental pressures in shaping species. The diversity of Arctotherium species that followed A. angustidens is a testament to the success of this adaptive strategy. At least 5 distinct species are recognized, each with its own unique adaptations. This diversity allowed Arctotherium to persist in South America long after its largest member had vanished, with some species surviving until as recently as 11,000 years ago. As new predators arrived in South America and prey populations changed, Arctotherium adapted by exploiting different ecological niches. The ability to utilize a wider range of resources would have given these bears an advantage in changing environments. This flexibility likely contributed to their long-term survival, even as their role in the ecosystem shifted dramatically from that of their giant ancestor. The Arctotherium's ability to adapt had kept them alive for millennia, but even evolution has its limits. As the last ice age drew to a close, these bears faced a perfect storm of challenges that would test their survival skills like never before. Approximately 11,000 years ago, the last known Arctotherium drew its final breath, marking the end of a remarkable evolutionary journey that had spanned millions of years. Extinction is the ultimate fate for most species, a biological full stop that represents the end of a genetic lineage. But what exactly pushes a species over that final threshold? In the case of Arctotherium, the answer lies in a complex interplay of environmental changes and new ecological pressures that unfolded during the late Pleistocene and early Holocene epochs. The end of the last ice age brought significant climate shifts, transforming South America's landscape. These changes altered the distribution of plant and animal species, reshuffling Arctotherium's food sources and habitat. The warming climate led to a decline in the large herbivores that these bears relied upon for sustenance, putting significant pressure on their survival. Compounding these environmental challenges, a new predator arrived in South America around 15,000 years ago: humans. While direct evidence of human predation on Arctotherium is scarce, the arrival of skilled human hunters coincided with the extinction of many large mammal species across the Americas. Humans likely competed with Arctotherium for prey and altered landscapes through various activities, potentially introducing new diseases as well. The combination of rapid climate change, prey species decline, and human arrival created an unprecedented set of challenges for Arctotherium. Despite their past adaptability, evolving from giant carnivores to smaller omnivores, the rate and magnitude of these changes may have outpaced their ability to adapt further. Fossil evidence suggests that different species of the genus disappeared at different times, with the last known remains dating to around 11,000 years ago. This gradual extinction highlights the complex nature of species decline, where multiple factors interact over thousands of years to ultimately seal a species' fate. The story of Arctotherium's extinction serves as a sobering reminder of the delicate balance of ecosystems and the far-reaching consequences of environmental change. It demonstrates how even the most successful and adaptable species can be vulnerable when faced with rapid, multifaceted challenges. As we grapple with modern conservation issues, the lessons from Arctotherium's story remain relevant. Extinction may have claimed Arctotherium, but nature has preserved a living connection to these ancient giants. Deep in the cloud forests of South America, a unique bear species holds the key to understanding its colossal predecessors. What secrets can this modern bear reveal about life in the shadow of giants? The spectacled bear, scientifically known as Tremarctos ornatus, is the last surviving member of the short-faced bear subfamily. This small, elusive creature roams the misty slopes of the Andes, carrying within its DNA the echoes of its prehistoric relatives. Standing at a modest 5 to 6 feet tall when on its hind legs, the spectacled bear is dwarfed by its extinct cousin Arctotherium angustidens. Yet this modern bear offers invaluable insights into the biology and behavior of its ancient relatives. While both species share herbivorous tendencies, the spectacled bear's unique adaptations to its Andean habitat provide fresh perspectives on Arctotherium's potential capabilities. These modern bears possess remarkable dexterity, using their paws to manipulate food and construct elaborate nests in trees. Such skills suggest that Arctotherium may have exhibited similar fine motor control despite its massive size. The spectacled bear's arboreal abilities offer another fascinating link to its prehistoric ancestors. These bears are excellent climbers, using their strong limbs and sharp claws to ascend trees in search of food and shelter. This skill may indicate that Arctotherium too was more agile than previously thought, potentially able to exploit diverse food sources in three-dimensional environments. Genetic studies have confirmed the close relationship between spectacled bears and Arctotherium, placing them together in the Tremarctini subfamily. This genetic link allows scientists to make inferences about Arctotherium's physiology, metabolism, and even potential behaviors. By studying the living spectacled bear, researchers can better understand how Arctotherium might have adapted to changing climates and environments over millions of years. However, the spectacled bear faces its own set of challenges in the modern world. Habitat loss due to deforestation and human encroachment threatens the survival of this unique species. Climate change alters the distribution of the plants they rely on for food, forcing the bears to adapt or relocate. These pressures echo the challenges that ultimately led to Arctotherium's extinction, providing a sobering parallel between past and present. Conservation efforts for the spectacled bear are crucial not only for the species itself, but also for preserving our last living link to the giant, short-faced bears of the Pleistocene. Protecting the Andean cloud forests ensures the survival of this remarkable creature and maintains the ecological balance of a unique ecosystem. By safeguarding the spectacled bear, we also preserve a living laboratory for understanding the biology and evolution of its extinct relatives. The story of the spectacled bear and its connection to Arctotherium highlights the interconnectedness of past and present ecosystems. It demonstrates how studying living species can shed light on extinct ones and how the challenges faced by modern animals often mirror those that led to prehistoric extinctions. As we work to protect the spectacled bear, we honor the legacy of its giant ancestors and gain valuable insights into the delicate balance of nature across millennia. The story of Arctotherium serves as a powerful reminder of nature's delicate balance. As we face unprecedented climate change and human impact on ecosystems, the fate of modern species hangs in the balance. Earth's largest known terrestrial mammalian predator offers both a warning and inspiration for today's conservation efforts. Many of our planet's iconic species are struggling to adapt to rapidly changing environments. By understanding the complex factors that led to the extinction of ancient megafauna, we gain valuable insights into protecting modern wildlife. The legacy of these prehistoric giants challenges us to act decisively, preserving biodiversity and maintaining the intricate web of life that sustains our world. As we reflect on the rise and fall of Arctotherium, we're reminded of our responsibility to safeguard the natural world for future generations.